Hello and welcome again. We're going to continue with the subnetting. We have done subnetting class C and now we're doing some examples in class B. It's actually quite easy to understand how subnetting works when you start with class C and then progress with class B and A. For class B, if you start with the basics, let's say one example, 172.16.1.0/16. This is what you would always see. And from design IP construction, I mean the octets are put in this way: N, N, H, and H, which means the N's are the network bits. The first two octets on the left, they are all ones, and these are network bits. So if we put all the ones here, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then 8 zeros here, another 8 zeros for the last H. Then you see, if you count here, you've had 8 and 8 and then 1 0 1 0. That means it's /16 if you combine 8 plus 8. And in the binary here, 8 ones, if you convert it to decimal, then it becomes 255. And then the other 255 for all 8 ones, and then the 0 here, and then 0 here. So this is subnet mask. This is the classful or the default class B. And if you want to now do subnetting, this will give you one subnet, and that subnet is large because it's /16. You will have a large IP subnet or a block size compared to class C we have gone through. Now, if we want to do subnetting and take an example, let's say 172.16.1.0, the same address, but instead of the default, we have 17. Now, what happened? The class C, you would know that it was NNHH, so you would say the first N was 1, 2, 3, 4, 5, 6, 7, 8, and the second N, 1, 2, 3, 4, 5, 6, 7, 8, and then here, if you add there 16, but in this case we have 16, so for octet number 3, we borrowed 1, and that means we have 1 over here, and then 7 zeros. 7 zeros. And then the other octet, the fourth, is still the same, no change, 4 zeros. You would expect N here, H here, and H here. But what happened? We are now mixing H and N together in this octet in here. So you have 1 and then 7 zeros, yeah, 8 together, 1 and 7 zeros. So if you now check, what we used to do is check the N, the borrowed bits, which is 1 over here, but then you have H, which is a large number. So you have to count 7 from here plus 8 here. So you have 15 N. If you want to count or calculate how many subnets you would have, it's going to be 2 to the power of N, which is 2 to the power of 1. And that means 2 subnets. You have now 2 subnets. And each subnet, you will have 2 to the power H minus 2 of valid hosts. So we'll say 2 to the power of 15 minus 2, which is 2 by 2 by 2 by 2 until 15 times. Yeah. So count 15 times. And if you do that, that's going to be 32,768. So 32768 minus 2, which will give you 32766 valid hosts. So if you compare the classful original class of class C, which would give you 254, from the block size of 256, you had the 2 subtracted, 1 for network, 1 for broadcast, that gives you 254. In this case, compare the 766's triple of 4 times, almost 4 times of, or 3 times of what you would get in one block of class C. But this is thousands, 32,000 IP addresses. So now we have a large host. So if you have a large organization with multiple IP addresses, then you can subdivide. This is your large subnet, and then you will create small subnets for different departments, different networks. So you have a large one. But the second thing to do is, what's the block size? And if you see, the block size to calculate is literally from here as well. Same as we did the calculation. But if we get a table and now put that value I put this one 17, and the network address will be the first IP from that subnet. So we have the 172.172.16.1, 172.16.1.0, and let me make it bigger so you can all see. So we can all see, that's good. Then let's go into a higher value and make it bold. Now if you see, the 2 octets that are subnetted are from here. And if you start the first one, you have one subnet and starting from 0 all the way to this number will generate, and the last 2 octets, these are the ones we are working on. So if it starts from 1 all the way to another number, this will be 0, 1, 2, 3, 4, 5, 6, 7, 8 until 255, and then that digit will be filled. So let me explain what I mean by that. So what we're looking for, if you have 172.16. whatever number here and that whatever number, these are the 2 numbers we need to deal with. So in our case we have 1 and 0, and for this digit to be full, let's say take this 2. For this digit to be full, we have 1 and 0. This should go 1, 1, 2, 3 all the way to 255. Only then this digit will turn from 1 to 2. So you will have 1, 255, and then as soon as that reaches the next number, this will be 2.0. So this is the end, like you have a stopwatch, and the stopwatch, when it completes 1 digit, the other digit gets started again. So we continue again 2.0, and then it continues to 1, 2, and all the way until you reach 255. That means 2.255, and then when the next number is going to be 3, and that turns 0. So this turns to 2, to 3. It goes on all the way to how many digits you have. And the way to calculate that is same like the class C. So we check which octet we are borrowing the numbers from. So this is the one, and in there we have 1 and 7 zeros. And if you have 1 and 7 zeros, that is in decimals, it becomes 128. So what's the block size then? You calculate from there. So if you move from 0, 1, 2, all the way to 127 is 1. And because you're saying block size is 256 minus 128, and that is 128 for one octet. The second octet will be turning from 0 all the way to 255, 0 to 255, and then the number will become 1. So 2 things you are calculating. One is that size, which is 128. So here the 1 will go all the way from 1, and then it will continue until it becomes 2, it will continue until it becomes 3, it will continue until it becomes 4.0, and then it will continue, that digit will become 4.255, and then it will change to 5.0, and then continue until it becomes 5.255, until it changes and it becomes 6.0, and it goes on. This digit at the end will become 127. That's the block size we're looking at. So if it's 128, it should start from 0 and end at 127. When it becomes 127 and you have 127.255, then if it fills, you become into the next block. So it becomes the second block, which will become 128.0, and then this will continue until it becomes 255, 128.255, and then it changes. It becomes 129.0, and this 0 will continue until it becomes 255, and this will stay 129, but the more you add, this will become 0, and then make that one 130 until you go all the way to 255.255. So now you have a digit that's changing from 0 up to 255, which changes the second digit from 1 to 2, all the way to 127. So you might be looking at a 0 to make it easier. You might put here a 0, so you know where actually things are starting. 0 here, 0 here. It's an easier example, to be honest. So let me change and show you how I fill a table. And here is our table, and I'm going to change that one to 0, so you know how things are changing. And this will become 0, 0, and the next number will become 1, 0.1. So we're checking the first digits. So remove this octets because these are not changing anyway. So we can change and it'll become 0.0. The next number would have become 0.1. The other one will become 0.2 until it goes to 0.255, and then followed by the 0 will change into 1.0, and then it will continue into 1. Maybe all the way to 255 until you reach the last number, which is 127.255. When you reach 127.255, the second number, this will change from 255 to 0 and will make this one 128. So you have 128.0, and then the next number will become 128.1 all the way to 128. This will become 1255, and then will become 129, for example, 129.255, and then you continue, it becomes 130.0, and then if you continue all the way, as this changes from 0 to 255, it will change this one from 128, 129, 130, 131, all the way to 255, 255. That's what you're getting. So if we remove those mirror numbers, and then if we stick on, let's actually leave, and yeah, let's remove all of them. So you see, I can now add back what I have, 172.16. The last two numbers is starting from 0, 0, and then this will become 172.16, and here the same, 172.16.128.0, and this becomes also 172.16.255. So if I ask you what's the first number we can use in this subnet, it will become 172.16.0.1. That's the first number. What's the second number? It's going to be 172.16.0.2. That way you will continue. This is the broadcast. What's the last usable one we can use? It is 172.16. Okay, I forgot the dot between the 16 and 127 there. And here we have 127.254. After you leave 54, you become in 255, and that's the broadcast. And the first number to use in subnet 2 is 172.16.128.1. And the last one you can use is 172.16.255.254. And that's the last usable IP. That's the broadcast. Then you can have your Excel sheet or spreadsheet where you can fill all these IP addresses and then assign the devices you need, subnets you need, or maybe you can create DHCP pools, and those pools assigned to different networks of your organization. And in another video, I will record how to subnet /18/19. Thank you again, and I'll see you in another video.